Good morning, class. We are looking at chapter 2, linear, absolute, and quadratic functions. We are covering 2.1 linear functions, 2.2 graphs of linear functions. And so in this chapter, we cover linear functions, graphs of linear functions, modeling with linear functions, absolute value functions, complex numbers, quadratic functions. The objectives are to calculate and interpret the slope of a line, graph lines given a point and slope, find the equation of a vertical line, use the point slope form of a line, identify horizontal lines, find the equation of a line given 2 points, write the equation of a line in slope intercept form, identify the slope and y-intercept of a line from its equation, graph lines written in general form using intercepts, find the equation of parallel and perpendicular lines, represent a linear function, determine whether a linear function is increasing, decreasing, or constant, interpret slope as a rate of change. And of course, we've seen that before, write and interpret equation for a linear function, graph linear functions. So, recall. Function. A function is a relation in which each element in the domain corresponds to exactly one element in the range. Domain, basically the portion of a graph that covers the x-axis. Range, the portion covering the y-axis, the portion covered on the y-axis. Vertical line test short, VLT. If a vertical line can be drawn so that it intersects a graph at more than 1 point, then the graph doesn't represent a function. One-to-one function. A function is one-to-one if each element in the range corresponds to exactly one element in the domain. In short, function, the x-coordinate doesn't repeat. One-to-one function, the y-coordinates cannot repeat either. Algebra of functions, f plus g is called the sum function is f of x plus g of x, f minus g is f of x minus g of x, fg is f times f of x times g of x, and the quotient function f over g is f of x over g of x. Needless to say, the denominator can't be 0. Composite functions, f of g is f of g of x, g of x, g of f of x. Two functions are considered inverse functions when their composite function is x, meaning f of f inverse equals f inverse of f equals x. When you have a curve, you pick up 2 points, you connect them, it's called a secant line. So these 2 points, we can calculate the slope of a line, rise over run in various methodologies. So if we go with A and B, this is the formula, f of b minus f of a over b minus a. If we call this x, becomes f of x minus f of a over x minus a, if this point is x. If this distance is h, then we have f of a plus h minus f of a over h, and normally this is called dq, the difference quotient. Absolute value by definition represents distance from 0, therefore absolute value of x is x if x is larger than or equal to 0, and negative x if it's less than 0. And because of that, the function works the same way. Absolute value of f of x is f of x is f of x is greater than or equal to 0, and negative f of x if it's less than 0. Absolute value of x equals a, and a is a positive value. X is plus minus a if it's less than a, and a is positive, is sandwiched between negative a and a. And if it's larger than a, absolute value of x larger than a, and again a is positive, x is less than negative a or larger than a. Here's the graph, a V-shaped graph. Domain is all real numbers, range from 0 to infinity. If you have a function y equals f of x plus c shifts it up by c units, we're assuming c is positive, minus c shifts it down, f of x minus c shifts to the right, f of x plus c shifts to the left by c units. So that's how it works. And again, the same function, we are assuming c is positive. If we multiply it by c, it stretches along the y-axis by c. If we divide it by c, it shrinks. Minus f of x, it's the same function flipped over with respect to the x. Or if it's f of minus x flipped over with respect to the y-axis. An even function f of minus x equals f of x, symmetric with respect to the y-axis. Odd function f of minus x is minus f of x, symmetric with respect to the origin. That is the synopsis of what we have learned. And now the new stuff, as far as the two sections are concerned, we are looking at 2.1 linear functions and 2.2 graphs of linear functions. Here's the summary. What we have seen, nothing brand new. M, or the slope, is rise over run. Change in y, delta y over change in x, y sub 2 minus y sub 1 over x sub 2 minus x sub 2. In a case of a vertical line, x equals a, slope is undefined, x-intercept at a0. In the case of a horizontal line, HL, y equals b, slope is 0, and y-intercept located at 0b. Two lines are considered parallel if they have equal slopes, m1 equals m2, different y-intercepts. They are considered perpendicular if they have slopes such that their product is -1 or they are negative reciprocal of each other. Lines, there are three formats. Standard form, ax plus by equals c. Slope-intercept form, you solve for y equals mx plus b. Point slope, y minus y1 equals m times x minus x sub 1. This is the summary as far as the lines are concerned. And I hope you all remember these formulas from algebra. All right. Calculate and interpret the slope of a line, rise over run. It is called the average rate of change of y with respect to x. By definition, slope represents the average rate of change of y with respect to x. So if you're looking at a vertical line, if you pick any 2 points, they have the same x coordinates. So when you put it into this formula, the denominator becomes 0, and therefore it's undefined, the slope. We want to find the slope for this line containing the two pairs. We put it into this equation. M equals y sub 2, -3, minus y sub 1, 4, over x sub 2, 2, minus x sub 1, minus -1. Class, this is minus -1. That's how we get this. This is important to understand how we arrive at this. And so the numerator is -7, the denominator is 3, and we get -7/3. All right. I'm going to do this pretty fast because, again, we've seen this many times before from algebra. Calculate the slopes of the lines containing the points and graph them on the same set of axes. So just for this, we just that in the previous page. For the sake of argument, if I want to calculate this, and I'll show you one and then the answer for all of them. If I want to calculate this, and I'm going to use this, I'm going to write -2, -3. This is the slope over -1, -2, -5 over -3, +5. So if I can get one of them, that means I can do all of them easily. And here's the answer to all of them. Okay, so pretty straightforward, everybody. I'm going to assume we can graph easily by simply plotting those pairs. For the sake of argument, if we look at the very first one only, so look at the first one. We have the pair 2, 3, and we have the pair -1, -2, just connect them. And that's the first line, L1, and you're done. It's that simple, everybody. Right? Makes sense? Same thing for the rest of it. What we want to notice here is the following. When the slope of a line is positive, like this one, the red one, the line slants upward from left to right. In other words, as we go from left to right, always x increases, so does y. This means a positive slope. So simply put, positive slope, x gets larger, y gets larger. When the slope of a line is negative, the line slants downward from left to right. For example, L sub 2. Take a look at this one, which simply put means x gets larger, but y gets smaller. Does that make sense? When the slope is 0, the line is horizontal because there is no change in the rise. They all have the same y coordinate. If you pick any number, any point, you have the same y coordinate. Any point, the y coordinate is 3. In fact, you can see, therefore, y equals 3 is the answer for the equation of a line. When the slope is undefined, you have a vertical line, in which case the x coordinates do not change. Okay? X coordinates do not change. So this is increasing, this is decreasing, and this is constant function, if you will. And this, a vertical line, is not a function. All right, graph lines given point and the slope. Draw the line that contains this pair 3, 2 and has this slope 3 and 4. And we are going to remind everybody of this. And so the methodology for that is you have a pair, use this to find another pair. Remember, the top is the change in y. So make this change for the y. That means add this to the y coordinate. Overrun. This is the change in x. Okay. So 2 is the y coordinate, gets added to the top, and the new y coordinate is 5. 3 is the x coordinate, and we add it to the bottom because the bottom is the change in x. 4 and 3 gives us 7. So we should recognize that. Add 4, the bottom, to x, 3, the top, to y, because the top is rise, the change in y, because of it, delta y over delta x. So now you have 2 pairs. and you can have the answer. Now, one change, just for the sake of argument, you could say, well, instead of adding, I'm going to subtract. So you can say m is minus 3 over minus 4. Just make sure you put negative sign for both of it. In which case, you say the top, instead of being added to 2, the top can be subtracted from 2. Or you can write it in this fashion. Instead of this, think about negative 3 over negative 4. Okay, so this, the bottom gets added to the denominator, becomes negative 1. The top gets added to the y coordinate, and we get negative 1, 1. Negative 1, negative 1, as an example. Just again, you can multiply this by 2 and say this is 6 over 8 and deal with 6 and 8. Okay, all right. What about this case? The top gets added. The top gets added to the y coordinates, so we get 6. The bottom gets added to the x coordinate, we get negative 2. Or you can subtract those numbers. In other words, instead of 4 over minus 5, remember this is the same as, let me use a different color. I can say this is the same as negative 4 over positive 5. Please understand these two fractions are the same. These two fractions are the same. So now, the bottom gets added to the x, becomes 8. The top gets added to the y and becomes negative 2, as an example. Okay, so rise over run, rise over run, rise over run. So to have an idea how to come up with more points. Vertical and horizontal lines. You should recognize this is a horizontal line. And so basically locate the x-intercept at negative 2, 0, and that's the line. However, you can put a few points. This is the most important point for me. Any vertical line has an x-intercept, no y-intercept. So just draw a line parallel to the y-axis or just a vertical line. If need be, you can give it a couple of points. So vertical line x has equation, the graph has an equation x equals a, with the slope being undefined. X-intercept is located at a0. We had this in the synopsis in the summary. Example 5, find the equation of a horizontal line containing this pair. Now, when we say a horizontal line, that means the y-coordinate doesn't change. So no matter what, the y-coordinate remains unchanged. Therefore, y must be negative 4. Remember, horizontal line y equals b. The slope is 0. Y-intercept located at 0, b. Okay, so this one has coordinates 0, 4. 0, negative 4. Okay, 0, negative 4. Different forms of a line, we've already discussed that. Standard form, ax plus by equals c. In short, x and y are on the same side. Slope-intercept form, y equals mx plus b. Solve for y. Solve for y, you get this one. Point slope, y minus y1 equals n times x minus x of 1. So we should know all. Find the equation of a line that has a slope of -3 containing the point -1, 4, and we're going to go with that, basically plug in. So y -4 equals m -3 times x minus -1. Of course, this is +1. We distribute the -3. We move the negative, becomes +4. And we can graph with the pair -1, 4 with the slope of -3. By the way, when the slope is an integer, you can write it as -3/1 or 3/-1 to find another pair. The bottom gets added to the x coordinate, the top gets added to the y coordinate, just as an example. So you see how we come up with the answer, okay? Again, if it's an integer, make it into a fraction. If you want to find another pair with that method, of course, right here, I hope you recognize you have 0, 1 as your y-intercept, 0, 1. This is -1, 4, so you really don't need to do much. Intercepts make it easier to have a more precise graph. If they don't ask you how to graph it, always use intercepts. As I said here, 0, 1. We want to graph the linear function. Of course, I would go with the intercepts, but just to give you an idea, I'm reminding you that if of x m is mx plus b, slope is m, y-intercept is 0, b, domain is all real numbers, range is all real numbers. So the y-intercept is located at 0, 1. M delta y over delta x is 2/3. So this is 0, 1. Slope is 2/3. Remember, you add the bottom to the x, the top to the y. So 3 and 0 gives you 3, 2 and 1 gives you 3. So you have 3, 3. So change y by value. Y value by 2, up by 2. If you want to go with that method. Change x value by 3, right by 3, which gives rise to the pair 3, 3, and put them together. However, besides 3 and besides 0, 1, I would set this equal to 0, meaning I do this. I say 0 because this is y. 0 is 2/3 x plus 1. Move the 1, 2/3 x. Multiply both sides by 3/2. We get -3/2 equals x, and that gives us -3/2, comma 0, which is this point. Okay, using intercepts. X is 0, find y. Y is 0, find x. Reminding you of this average rate of change. So you have a curve, you connect two pairs, 2 points. You can call them x sub 1 and x sub 2. So this becomes f of x sub 1 and f of x sub 2. That's one way to look at it. So average rate of change, the difference quotient. Delta y over delta x is f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1 is called the average rate of change of y or f of x with respect to x over the interval of x sub 1 to x sub 2 and can be interpreted as the slope of a secant line PQ. This line is called the secant line, everybody. Now, we remember this formula. We may use A and B, so it becomes this formula. We may use X and A becomes this formula. We may use A with the distance of H. This is A plus H becomes this formula. Please understand, all of them are the same. Slope of a secant line. You need to be very comfortable with this, known as a DQ, difference quotient. Determine whether a linear function is increasing, decreasing, or constant. So I remind you, when f of x is mx plus b, so we have a slope-intercept form. It is considered increasing when the slope is positive, decreasing when the slope is negative, and constant when the slope is 0. So for example, this one, the slope is -2, therefore it's decreasing. G of x equals 5 or y equals 5, that's a horizontal line, the slope is 0, makes it constant. The slope is 3/4. It's a positive slope, therefore it's increasing. Same thing here. This is a function of z. The slope is 1, 1, and it's positive, and it's increasing. Given the function, determine the slope and y-intercept, graph the function using the slope and y-intercept, determine the average rate of change, and determine whether the function is increasing, decreasing, or constant. First and foremost, when we find the slope, that is the average rate of change, just to let you know. So, for example, here, the slope is 3. That's the average rate of change of y with respect to x. That gives us the y-intercept of 0, 5. And we can find the x-intercept. If you set this one equal to 0, okay, I hope you see that x becomes -5/3. I hope nobody has any problem calculating this fast. And it's an increasing function because the slope is positive, +3. And I'm going to assume we can use those two pairs easily and graph and look at 0, 5 here, -5, there's 0 here. And that's the graph. And again, m is positive, is increasing. The other one is that when it's asking you determine the average rate of change, the answer is m equals 3. That's it, average rate of change. When we look at this one, the average rate of change or the slope is -4 and the y-intercept is 0, 2. If I set this equal to 0 to find the other one, x-intercept, so if I set this one 0, x becomes 1/2. So 1/2, 0, and this is negative, so it's decreasing. So again, a recap. The slope is -4. It's negative, makes it decreasing. The y-intercept is 0, 2. Set this equal to 0, x is 1/2, 0. And by the way, the slope is the average rate of change. And plot the two pairs. You have 0, 2 here, 1/2, 0 here. By the way, the scale on the x and y axis can be different, okay? Finally, f of x or y equals 5. This is a horizontal line with the slope of 0 and the y-intercept of 0, 5, which means the average rate of change is 0. The function is constant. The function is constant. There is no x-intercept. So draw a horizontal line with the 0, 5. So this is 0, 5, and that's the line. Okay, so just for the sake of argument, we will put here 0, 5. Find the equation of a line given 2 points. Find an equation of a line containing the points -1, 4, 3, -1. By the way, you can plot those pairs easily and graph them. That's not a problem. However, if you want to come up with the equation of a line, the very first thing is to find the slope, rise over run. So -1 -4 over 3 minus -1. This is -5. And this is +4. You can put the negative sign at top, the bottom, or in front of a fraction bar. I'm going to use this one, y minus y1. And we use one of these points, and pay attention to what I want to tell you. First, use one of the points, y minus 4 equals -5, 4 times x minus -1, which means +1, right? Now, if you apply -5 over 4x minus 5 over 4 on the right side, move the -4 and make it +4 on the right side, combining these two. 4 is 16 over 4, class. 4 is 16 over 4 with -5 over 4 is 11 over 4. This is the line. First, I want to show you how to check your work. We did not use this pair. So we are going to check to see if this pair works. If it does, we have come up with the correct equation of a line. Okay, so you must check, and you should check with the other point. So if I put 3 here, I get 3 times -5, -15 over 4 plus 11 over 4 is -4 over 4 or -1. So let me quickly show you. If I put so y is -5 over 4 times x, which is 3 plus 11 over 4, which is -15 over 4 plus 11 over 4, which is -4 over 4, which is -1, and it checks. See how you check it? Very simple. Now, you can plot the pairs -1, 4 and 3, -1 and connect them, and you're done. And by the way, 0, 11 fourths, okay, Remember, 12 over 4 is 3, so a little bit less than 3 is the y-intercept, and I'm going to leave it for you to find the x-intercept. You can practice that. Find the slope m and y-intercept b of the equation 3x minus 2y equals 6 and graph. Of course, you have to solve for y. So given the equation, move the 3x, make a negative 3x on the right. Divide by negative 2 both sides. You get 3 halves, y equals 3 halves x minus 3. And clearly, the slope is 3 halves. And the y-intercept is 0, negative 3. So the slope is 3 halves. B is negative 3, meaning we have the pair 0, negative 3. That's the meaning of it, okay, everybody? Now, we can find the x-intercept and graph it. Or if we want to go, let me quickly show you both methods. Using the slope, remember this gets added to the x coordinate, we get 2, and this gets added to the y coordinate, and we get 0. In fact, that is the x-intercept anyways, but that's how you find the new point, and that's the line. Or over here, set this one equal to 0 and solve it, and it gives you 2 anyways. Either way. So very straightforward. By the way, almost always we are interested in slope intercept form, okay, everybody, because that's unique. Graph the linear equation 3x plus 2y equals 6 by finding its intercepts. So that's a standard form where a, b, c are real numbers, a and b are not 0, not both 0. One of them can be 0. So replace the x with 0, you find y. Replace the y with 0, you find x. That's the bottom line. So if you set y equal to 0, in fact, you can say this is gone. So 3x equals 6, x equals 2. So this means this pair. That's the meaning of it. Now, set x equal to 0. Ignore that 2y equals 6, y equals 3. So that's the x-intercept, everybody. You work on this. And this means 0, 3. And there you have it. Very straightforward, very simple. Find the intercepts, connect them, graph. The beauty of the intercepts is that it's precise, okay? So I highly recommend, if they ask you to graph and no more instruction, always use intercepts. That gives you an exact graph. Parallel and perpendicular lines. Parallel lines. Two non-vertical lines are parallel if and only if they have equal slopes and different y-intercepts. M1 equals M2, B1 is not equal to B2. So two lines are parallel. Here's a proof. If you look at this, if you drop a perpendicular, okay, if to the x-axis and drop a perpendicular to the y-axis, so this part is parallel to the y, this part is parallel to the x for both cases, okay? Then you do that for both. The right triangles are similar. Why is that? Well, this is a 90-degree angle. These two lines are parallel, and this creates these two interior angles that are identical. And therefore, If two angles are the same, the third angle must be the same. The two triangles are similar, meaning corresponding angles are equal, corresponding sides are in ratio. So with that being the case, delta y over delta x, the rise over run, delta y over delta x, rise over run, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. In both cases, this ratio is the same because the two are similar. So the ratio of corresponding sides are equal. Rise over run is identical for both cases because they are similar figures. We are not saying this rise is equal to this rise, this run equals to this run. We are saying the ratio because that's the definition of similar figures. And again, why are they similar figures? They have equal angles. In the case, so M1 equals M2, but B1 is not equal to B2, meaning if B1 is equal to B2, they become the same line, by the way, right? Meaning they are parallel. Perpendicular lines. Two non-vertical lines are perpendicular if and only if their slopes, M1 and M2, are negative reciprocal of each other, meaning there are a few ways to write them. M sub 2 is negative 1 over M sub 1, or M sub 1 times M sub 2 is negative 1, or M sub 2 is negative 1 over M sub 1. So they make a 90-degree angle at the point of intersection. So we want to quickly look at the proof, but understand one easy way, their product is negative 1. So to do that, to make it easy to prove, we are looking at proof of the criterion of perpendicular lines. Let us choose the lines, the two lines are perpendicular, such that they intersect at the origin. On purpose, we want to do that so it becomes easy to prove that. So we know this is a 90-degree angle because they are perpendicular. And pick a point on each line with the same x coordinate. So draw some vertical line. Okay, so this is it, this is it. And it crosses both lines, which means they have the same x coordinate. Okay. Now that x coordinate can be any number, 1, 2, 5, 1.5, 8, 9, 2, you name it. Why do we choose x equals 1? Again, to ease the process. I can pick any vertical line. The reason I pick up a vertical line because I want the x coordinates to be identical. They can be 1, both of them, or 2, or 10. Makes no difference. It will prove, but 1 is the easiest number to work with. Let's choose x equals 1. Consequently, the y coordinates of these points become equal to their corresponding slopes y. The reason we choose 1, because if the x coordinate is 1, for this line, which has a slope of m1, the y coordinate becomes m1. This point, x coordinate is 1. The slope of this line is m2. The y coordinate becomes m2. Why is that? Let me quickly show you. The reason is we know this point has coordinates 0, 0. And we know the slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So if we assume it's m sub 1, we see that it works out. If we don't know that, if we don't assume it's m sub 1, let's say we don't know it, put a, let's say, I don't want to put x, actually, let's put some other variable. Let's put t. Then t equals m1, okay? Because the slope is m1, therefore this becomes m1. So that's the proof in any way. Now, we are looking at this triangle, which is a right triangle. So Pythagorean theorem says, because they are perpendicular, making 90 degrees angle, OA squared and OB squared is AB squared. So this one squared plus this one squared is this one squared. That's what I'm saying. They are perpendicular according to the Pythagorean theorem. OA squared plus OB squared is AB squared. And the distance formula is square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. So because we are squaring it, we are not needing the square root. So what is OA? This distance. 1 minus 0 quantity squared plus m sub 2 minus 0 quantity squared for OA. These two. 1 minus 0 quantity squared plus m sub 1 minus 0 quantity squared. So this is OA squared. This is OB squared. This is not needed. And what is AB? According to this formula, 1 minus 1 squared plus m sub 2 minus m sub 1 squared. All you have to do, expand and observe. So this becomes 1 squared, this becomes m sub 2 squared, this becomes 1 squared, this becomes m sub 1 squared. So that's the left side. This is 0, so goes away. M sub 2 squared minus 2m sub 1 m sub 2 plus m sub 1 squared. I'm assuming nobody has any problem with a plus b squared, so I'm going to quickly remind you what I'm using. A plus b squared is a squared plus 2ab plus b squared. If this is negative, this is negative. That's what we are using, the identity. M sub 2 squared cancels out m sub 2 squared. M sub 1 squared cancels out m sub 1 squared. The left side, we have a 2, and the right side, negative 2 and 1 and 2. So you can see that you can divide it by 2, or you can say m2 is negative 1 over m1. Believe it or not, that's the proof. If you could follow the proof, you're in good shape. I'm not going to ask you for the proof, but it's good to follow the proof. All right, show that the two lines are parallel, perpendicular, or neither. The first line is negative 3x plus 2y equals 12, and the second one is 6x minus 4y equals 0. All you have to do is solve for y. So in this case, we're going to move the negative 3x. Divide both sides by 2. And the slope is 3/2. The y-intercept is 0, is 6, which means the pair 0, 6, okay? For the second line, we do the same thing. We move this one. We divide by negative 4. Both sides. And x becomes 3/2. The slope is the same thing, 3/2. Y-intercept is 0, 0, which says the two lines are parallel because the slopes are identical. And you can graph them. I'm going to assume everybody knows how to graph them. You have those pairs, you can pick another pair easily. Find an equation of a line that contains this pair and is parallel to this line. Well, first and foremost, we have to solve for y to find the slope of the given line, which means we're going to move the 3x. We're going to divide both sides by -4, and therefore the slope is 3/4. And because we want it to be parallel to that, both of them have, so we're going to call it m sub 1 and m sub 2. M sub 1 is for the given line, m sub 2 for the line parallel to that. And so we are going to use y minus y1, that means y minus 3, equals m, which is 3/4, x minus -1 or +1. And this is, of course, +1. So y minus 3 is 3/4 x plus 3/4 plus 3. Remember, 3 is 12/4. So we get 15/4. And we can graph. I'm assuming by now nobody has any problem. You can pick up 2 pairs and graph. Okay. Just to give you an idea for this one class, the original one, if x is 0, please see, if x is 0, just cover 3x and you get 0, -3. If y is 0, then cover -4y, 3x equals 12. Okay, 4, 0. And so you can do the same thing for the other one. The next part, perpendicular to the same line. Now, the slope was 3/4 for the perpendicular is the negative reciprocal. So this one has a slope -4/3. -4/3. So y minus y1, that means y minus 3 equals m. Now this m, -4/3 times x minus -1. And this is +1. So y minus 3 equals -4/3 x -4/3. We are going to move the -3 and make it +3, or 9/3 with -4/3 becomes 5/3. And again, you can graph them as follows. And this line is the same line here, the line perpendicular to that. You can pick up a couple of pairs to graph it. All right, in this example, example 15, given A with coordinates -3, 1, and B with coordinates 5, 4. Find the equation of the perpendicular bisector L of the line segment AB. So you plot A and B, and the bisector is a perpendicular line that cuts it in half, in short. A line bisector cuts the line segment into two equal parts. In this case, the line segment AB is being cut into two equal lengths by the bisector line L. If the line L crosses at a right angle, it is called the perpendicular bisector of AB. Otherwise, it is simply a bisector. So we have A with coordinates -3, 1, B with coordinates 5, 4. Connect them, and we want to find the bisector. We want to find this line. And to find this line, the concept of a bisector is to cut it into equal parts. So we are looking for the point which is the midpoint. X sub 1 plus x sub 2 over 2 plus y sub 1 plus y sub 2 over 2. That would be the coordinates of the midpoint. Therefore, -3 and 5 divided by 2, 1 and 4 divided by 2. These two give us 2 over 2, which is 1, 5 over 2. So that's the midpoint. M having coordinates 1, 5 halves. Now, we want to find the equation of a line that contains this. So all we need is the slope of this line. So what is the slope of the bisector? Well, we can find the slope of AB, and because bisector is perpendicular to that, we use the fact that their slopes are negative reciprocal. So for AB, the slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That means 4 minus 1 over 5 minus -3. That means 3 over 8. This is the slope of a blue line that contains A and B, but we want a perpendicular line to that. So what we want is the negative reciprocal. So the PB, I'm going to call it the bisector, the slope is -8, or perhaps maybe we want to use the L, the line L. How about that? That may be even better. The line L has the slope which is -8/3. So using this formula with this pair and this slope. So y minus 5 halves equals -8/3 times x minus x sub 1. X minus x sub 1, which is 1. Distribute, you get -8/3 x plus 8/3, and -5 halves moves, becomes +5 halves. Now you want to add these two. The common denominator is 6. So 2 times 8, 16, plus 3 times 5, 15. We have 31 over 6. So I hope we understand this is the equation of a line. And of course, 0, 31 over 6 is clear. That is the y-intercept for that line. And you have this point, you can connect them. If you want the x-intercept, you set this one equal to 0, and you get 31 over. If y is 0, x is 31 over 8. But in any event, this is the line that we are interested in. You don't have to find all intercepts. So by the way, in case somebody says, okay, what is the equation of the line AB? They didn't ask, but why? You can use the same point, or you can use this one or this one. If you use the same point, y minus 5 halves equals now the slope of AB is 3 over 8, everybody, 3 over 8 x minus 1, and you go through the process and you get this one, in case that wasn't the question, okay? All right, let's continue. Find an equation of a line that contains this pair, 1 comma negative 2, and is perpendicular to this line. So we have to solve for y, which means move the x and then divide by 3. If you divide by 3, this is the pair, by the way, you can find those two pairs. Let me just actually erase this for now, because if x is 0, if x is 0, y is 2. If y is 0, x is 6. And you can graph those lines. That's not a problem. Now, the line that contains this one is perpendicular to that. So we need to find the slope. Move the x and divide by 3. So this is x plus 3y equals 6. Move the x and divide by 3. So you get 3y equals minus x plus 6. And now, if you divide by 3, you get this, which gives you the slope of negative 1/3. The slope of the given line is negative 1/3. The slope of a line perpendicular to that is the reciprocal of that times negative, so it's positive 3. Y minus y1, that means y plus 2, y minus negative 2, equals m, which is 3 times x minus 1. And that's very straightforward. We have 3x minus 3. I'm going to subtract, and we get 3x minus 5. Now, clearly, 0 minus 5 is the y-intercept. If you set y equal to 0, x becomes 5/3, 5/3, 0. So plot 0 minus 5, 5/3, 0, connect them, you're done. Y equals 3x minus 5, the perpendicular, and it makes a 90-degree angle here. Given f of x equals 3x plus 6 and g of x equals minus x plus 4, solve for f of x equal to 0. Well, set this equal to 0. Move the 6, divide by 3, and x becomes negative 2. This is elementary, okay, everybody? F of x is greater than or equal to 0. Basically, the same thing, but greater than or equal because you move the 6. And divide by 3. And you're done. But in interval notation, this would be bracket negative 2 to infinity. F of x equals g of x. Set the two functions equal. Add the negative x to the other side, becomes positive x. Subtract the 6. And 4x is negative 2. And there you have it, x equals negative 1/2. F of x is less than or equal to g of x. So basically, I hope you recognize, because we solved this, the answer to this would be the same thing, but less than or equal. So put this sign here. So we go through the process, divide by 4, and we get the same sign here. Because we are not dividing by a negative, it doesn't flip over. So, and that is correct if you want to put it in interval format. This means from negative infinity to negative 1/2. Negative 1/2 is included because of the equality, therefore we use brackets. Last question, given the data, plot the pairs and use the average rate of change to determine if the function is linear. So as far as plotting, I'm assuming if x is 20, which represents the age, and the maximum number of heartbeats is 20, 50, you plot that. The next one, 30, 47.5, and so forth. So plotting the pairs, I'm assuming it's not a problem. If you connect them, there seems to be a straight line. And therefore, it is linear. However, we can show it mathematically by calculating the average rate of change. That means pick any two pairs and calculate y sub 2 minus y sub 1 over x sub 2 minus x sub 1. For example, we pick these two pairs, the first two pairs. That means 47.5 minus 50 over 30 minus 20. That's how you calculate it. And this is negative 0.25. Then you calculate for these two, and then these two, and these two, and these two, and you put them in front of it. So again, we calculated for these two. Now for these two. Now this one and this one. Now this one and this one. Now this one and this one. You have to calculate all of them. They all end up having the same value. Since the average rate of change is a constant negative 0.25, the function is linear. If the answer is this or close to that for all cases, because it may not be identical when you're looking at applications. This is age versus heartbeats, okay? There are more heartbeats on a regular basis for younger adults. And therefore, this number may not be exact, but if it's very close to that, that makes it linear. That's the idea.